All right, we are going to be looking at Learning Target 19. I can apply the properties of integer exponents. We will be focusing primarily on multiplication with exponents. So as we discussed in the last video, exponents are attached to a base, and it is a way for us to show repeated multiplication. So if we look at our first example here, we have 2 to the fourth times 2 to the second. So 2 to the fourth indicates that we have 2 times itself 4 times. And then we are multiplying that by another set of 2, another base 2, multiplied by itself twice. So if I were to simplify this, I can see that I have a base of 2 multiplied by itself 1, 2, 3, 4, 5, 6 times. So 2 to the fourth times 2 to the sixth would be simplified to, 2 to the fourth times 2 to the second would be simplified to 2 to the sixth power, which if we were to simplify even further would be 64. Looking at the second example, we have 4 to the fifth. So if I were to write that in expanded form, that would be a base of 4 times itself 5 times 4 times itself 4 times, which if I wanted to simplify, it would be a base of 4 multiplied by itself 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times. So we would get 4 to the ninth power. If I wanted to write that in standard form, that would be 262,144. So what this expanded form allows us to see is that when we are multiplying common bases, we have what is called the product rule. So when multiplying the common base, you are going to add the exponents. So if we look up at that very first example, we had 2 as our common base, and then 4 plus 2, that equals 2 to the sixth, which is what we had originally found. If we look at our second example, we had 4 to the 5 plus 4, which equals 4 to the ninth. 4 to the ninth, which is what we had originally found. Now, some things to keep in mind. Sometimes you will have coefficients. If that is the case, you do have to be careful because you're going to multiply the coefficients, but then use the product rule to simplify the variables. So to look at our first one here, we have x to the third power times x to the seventh power. X is our common base, and then I am going to add those exponents. So x to the third times x to the seventh is going to give me x to the 10th. In my next example, I have 3 terms. However, they all have the same base. So I'm going to have 10 as my base. And then I'm just going to add all of the exponents. So this would be 10 to the 12th. Looking at the example after that, I notice here I have coefficients. The 5 and the 2 are those numbers that are in front of the variable. They are not the same, and so for those, I am going to multiply. So 2 times 5 is 10. And then I'm going to solve my exponents separately. So x to the sixth times x to the fifth. That would give me x to the sixth plus 5. So my final answer would be 10 times x to the 11th power. Notice the 10 does not have the exponent, only the x. Looking at the last example here, I see that I have coefficients. Be careful. I have a 2 coefficient, and then my coefficient on the C is technically 1. If it's not written there, it is 1. All right. And 2 times 1, we know, is 2. And then I would work with my common bases. C to the 8th times C to the 4th. That would be C to the 8 plus 4, which equals 2 times c to the 12th. All right. Go ahead and add any questions you have to the Ed puzzle, and I will check in with you.